Hello, Calculus 1 class. This is Professor Ken, and today's video is for class of January 23rd. And today we're going to learn all about composite functions. All right, so let me begin by sharing my screen. And let's go to today's PowerPoint presentation. Now, when you watch your own I put the slides up. So when you're going through the slides, the best way to do this is always by doing it through a slideshow. So if you click on slideshow and click from the beginning, and then you use your mouse to click your way through, that is the absolute best way to learn. Let me actually turn my video off so my beautiful face doesn't get in your way. Okay. Something's wrong. The animations didn't work. Not the animation, the transitions are not working. Hold on one second. I apologize for that. Okay, let's start this again. I apologize. Okay. So by the end of today's class, you'll be able to compute composite functions. You'll be able to evaluate composite functions, and you'll be able to solve problems involving composite functions. So let's begin. Suppose we have three functions, f of x, g of x, and h of x. We could see what their values are up top. What if we want to calculate f of -3? Now, this is obviously a review. To calculate f of -3, we look at f of x. Wherever we see an x, which is right here, take it out and put in a -3. We do the same thing for g of 5 and the same thing for h of 1/3. So for solutions, 2 times -3 minus 1 is -6 minus 1, which equals -7. For g of 5, it would be easy one, just 1/5. And for 1/3, we can't be scared of fractions if we're calculus students. So this is the square root of 1/3 plus 1. 1/3 plus 1, another name for 1 is 3/3. 1/3 plus 3/3 is 4/3. The square root of 4/3 would be 2 over the square root of 3, because the square root of 4 is 2, and bring down the square root of 3. All right, so that's a quick little warm up on how to evaluate functions. Now we're going to continue with these same three functions throughout the lesson. What if we have f of w, g of 16 minus pi, and h of 99? Well, once again, we just take the x out and put whatever's in the parentheses inside. So f of w would be 2w minus 1. G of 16 minus pi would be 1 over 16 minus pi. And h of 99, well, 99 plus 1 is 100, and the square root of 100 equals 10. So far, nothing so earth-shatteringly difficult. Right? But if we have sometimes we're going to see functions within functions, and that's called a composite function. So for example, f of g of 2 means take g of 2, which is on the, we always want to start with the inside and put it into f of x. Well, what is g of 2? G of 2 is 1/2. So put 1/2 into f of x, and we get 2 times 1/2 minus 1. 2 times 1/2 minus 1 is equal to 0, which I didn't write in there, so let me do it now. Equals 1 minus 1, that equals 0. All right. So f of g of 2 equals 0. Okay. Does not equal -1. I made a mistake. Equals 0. I'll fix that. Okay. Let me, in order for me to get rid of this, annotate. Annotate. Okay, clear. All right, there we go. Okay. Okay, same functions. Now let's try g of h of e. So let's pause the video, and I want you to work after I say the word pause again, and then I want you to work it out. Keep in mind, you're going to calculate h of 8, and then you're going to take that value and plug it into g. So first find h of 8. That equals 3 because 8 plus 1 is 9. Square root of 9 is 3. Plug it into here, and we get g of 3. And what does g of 3 equal? 1/3. Not so hard. Now you try g of f of 18. So put it on pause and calculate away. Welcome back. F of 18 is 35. H of 35 is 6 because 35 plus 1 is 36, and the square root of 36 is 6. Same three functions. Now we'll do a composite function where we're not evaluating, but we're computing. That means take one function and put it into another and simplify. So g of f of x. So f of x is 2x minus 1. We take that 2x minus 1 and we put it into g. So here goes. F of x equals 2x minus 1. So it's g of 2x minus 1, and that's just 1 over 2x minus 1. This is not hard stuff. Easy peasy. Here's our same three functions again. Now you try h of f of x. So hit pause and compute. Welcome back. F of x is 2x minus 1. We take that and we throw it into h. So we have h of 2x minus 1. That's 2x minus 1 plus 1. The negative ones, the ones cancel. So it's just the square root of 2x. You don't even need those parentheses. Now you try g of h of x. Put it on pause. You should get 1 over the square root of x plus 1 because h of x is the square root of x plus 1. Put it in for x over here where g is. And we get 1 over the square root of x plus 1. Hopefully you're getting the hang of this. All right. Another way to write a composite function is called f circle g. And, oops, I want to actually annotate this because the way the book writes this is also equal to f circle g. You put all that in parentheses, and then you do the of x over here. So that's how you're going to see it in the book often. I just wanted to make, it's not often put that way, but it is in our book. So don't get scared. F circle g just means f of g of x. So you see f circle g, you think of f of g of x. And you were good at that. So let's evaluate h of g of x. And again, it'll be written this way in the book. That means h of g of x. Take your g of x and put it in over here. So since g of x is 1 over x, h of 1 over x is the square root of, you just take this x out and put it in 1 over x. It's the square root of 1 over x plus x. Now, we need to simplify that. Think of x as x squared over x because we need a common denominator. So 1 over x plus x squared over x would be 1 plus x squared over x. So h of g of x is equal to the square root of 1 plus x squared over x. If you just wrote it this way, that's pretty darn good. So this is just the simplified version. Let me clear all drawings. All right. Starting to get good at this. All right, here's our function. So it could get more intricate, but not more difficult. That means it may get messy, but doesn't make it harder. So look at this, f circle h. That means f of h of x. That's how we would write it, f of x, f of h of x. So don't worry, just start with the h of x and work your way out. So we'll take h of x, which is right here, we'll put it into f of x, and we'll get a value. Then we'll take that value and put it back into f of x again. So h of x is the square root of x plus 1. So f of the square root of x plus 1 is 2 square roots of x plus 1 minus 1. Just take that x out and put this in. And that can't be simplified any further. Then when we do f of h of x, okay, here it is. So we're going to take all of that and put that into f of x. So it's f of 2 square roots of x plus 1 minus 1. So we take 2 square roots of x plus 1 minus 1, and we throw it into, we take the x out, and we put in 2 square roots of x plus 1 minus 1. So it's 2 times 2 square roots of x plus 1 minus 1 minus 1. Now we have to distribute this 2. So 2 times 2 is 4, and 2 times negative 1 is negative 2. So it's 4 times the square root of x plus 1 minus 1 minus 2 minus 1. Negative 2 minus 1 is negative 3. And there's our final answer. And I love circling my final answers after they take many steps. That's another reason why you should watch this as a slideshow and not just as a slide deck. All right, here's our functions again. Now let's evaluate h of f of g when x equals 1. What does that mean? H of f of g of negative 1. So g of negative 1 is negative 1. How do we know that? Because 1 over negative 1 is negative 1. Now we have to do h of f of negative 1. So we took the g of negative 1 out and put a negative 1 in. So now we do f of negative 1. That's not so hard. F of negative 1 would be negative 2 minus 1 is negative 3. Then we take that negative 3 and put it into h. So it becomes the square root of negative 2. But we have to be aware now, because the square root of negative 2 does exist under the set of complex numbers, but it doesn't exist under the set of real numbers. So let's solve for some problems. All right, look at this function h of x. It says h of x is equal to 3x to the 6th minus 4x cubed over all of that squared. Let me say that again. H of x is equal to 2 over 3x to the 6th minus 4x cubed quantity squared. We're going to write that as a compact composite function. How do we do that? We have to identify an inside and an outside function. So let's call the inside function what's in the parentheses. Then the outside function, you just take what's in the parentheses, put an x there, and that's your outside function. So the outside function would be 2 over x squared. So the inside function is f of x, which is 3x to the 6th minus 4x cubed. And the outside function is g of x, which is just 2 over, take the inside function out and replace it with an x squared. So if f of x is 3x to the 6th minus 4x cubed, then g of x is 2 over x squared. So the composite is g of f, or g of f of x, same thing. And if you want to go back and prove it, you may do that. I probably should have done it, but I didn't. There's more than one solution to this. So if we were to write this as a complex, as a composite function, we could call the inside function the whole denominator. So then we would just have 2 over x as our outside function. So it's another way to do it. All right, and the last type of problem to solve, suppose g of x equals x squared plus 3. Find f of g of x if it's equal to x to the 4th plus 6x squared plus 9, then find f of x. Let me say that again. If f of g of x equals x to the 4th plus 6x squared plus 9, then find f of x. Don't panic. Breathe, think. When you get scared, breathe in through your nose and out through your mouth. Then think and never panic. So we know from algebra that x squared plus 3, which is g of x, to the 2nd power is our entire function. So what we're trying to find out is just g of x squared. So the outside function would be x squared. So therefore we already know g of x, and the outside function is x squared. So f of x would just be x squared. So the biggest tip is to work from the inside out. So if we have these two functions and we're trying to compose g of f of x, well, start off with the inside and put it in the outside. So we would take that x minus 1 and take the x out, put x minus 1 in. So it's x minus 1 quantity squared plus 4. That's x squared minus 2x plus 1 plus 4, which is x squared minus 2x plus 5. And you know I love to circle my problems. So that's it. It should really take you about an hour and 15 minutes to go through these slides because you should be pausing, thinking, working problems out, and taking notes. I hope you found this to be a great learning experience. Have a nice day.